Okay, so we're being asked to add these. They are not like denominators, correct? So we need to make them like denominators. So, like the video yesterday said, one of the ways to do this is to take your two denominators and multiply them together to be your common denominator. I'm going to leave this as two separate ones first. Sorry. So that's what my common denominator would be. So for the first fraction, I already had the 15x squared y, right? So what I multiplied by was that 12xy squared. Well, if I multiply it in the denominator, I have to do the same thing to the numerator. So I have to multiply that by the numerator also. And then on my second fraction, I had a 1 here over the 12xy squared, but I need to multiply by the 15x squared y. Okay, so any questions there? So do you guys see what I did? It's by multiplying by this form of 1 to get that common denominator. Okay, once we get the common denominator, now I'll put it all over 1. And let's clean up our numerator, so to speak. So this is going to be 24xy squared plus 15x squared y. Okay. Can I combine those two in the numerator together? No. Okay. Can I multiply across the denominator? Probably, huh? But up there in the numerator, are there any common factors that I could divide out? 3 and x, y, right? So what would be left? 8y plus 3x?
5x.
5x. Thank you. Now, this bottom stuff needs to get multiplied together. But I'm going to hold off on that. Because is there something that cancels from the numerator to the denominator now? Okay, so this is all stuck together, right? So there's nothing that I can multiply with that on the in the denominator. But I'm just going to rearrange this a little bit. So I have 15 times 12, x squared times x, y squared times y. Okay? Is that the same thing I had up there? 15 times 12, x squared times x, y squared times y. Yeah. So it's just a string of numbers and variables all multiplied together, which now I can cancel. So can I cancel my 3 with something down here? Well, 3 will divide into 15 and become a 5, right? This x can cancel with this x. This y can cancel with that y. So we have 8y plus 5x equals 60 x squared y squared. Is there anything else we could do? From right here? Well, I did the 3 into the 15. You can't do it to both. You could have put it into the 12 and made this a 4, but then it would have been 4 times 15, which would have still been our 60. Okay, so we're done. Okay. There's just another example there. I forgot to record the whole step-by-step. So pay close attention to detail as you're going along. The other thing that I've probably preached and said no photo math, right? You shouldn't be using photo math to do your problems. But there's a place to use photo math. And this might be it. If I do this problem on my paper, okay, and I don't get the correct answer, I'm going to go back and look, make sure that I factored right, make sure that I've distributed and combined right. After that, if you look and you can't find your mistake, pull it up on PhotoMath and compare and learn from your mistake and PhotoMath where you made your mistake from. Okay? Don't use PhotoMath to do the problems the first time. Use PhotoMath to check your work. Then, if you really want to hold yourself accountable to make sure that you've learned it, regenerate a new problem if it's the ones that are on going to varsity, and then do a new problem yourself. Okay? You can't do that on the worksheet as much, but you guys get what I'm trying to say there? Yeah, okay.